Previously, we did a video on Q-learning. In this video, we will demonstrate another value-based learning known as SARSA. SARSA stands for State, Action, Reward, State, Action. The difference between these two algorithms is that SARSA chooses an action following the same current policy and updates its Q values, whereas Q-learning chooses the greedy action, that is the action that gives the maximum Q value for the state. That is, it follows an optimum policy. In other words, SARSA is an on-policy algorithm and Q-learning is an off-policy algorithm. Again, we will demonstrate SARSA on OpenAI gym environment. We will again pick a simple taxi v3 environment for illustration. First, we will import the gym libraries and create a taxi v3 environment. Next, we will initialize all Q tables to 0. We will see the performance of the model before reinforcement learning. We started with a random state and choose a random actions since all the Q values are 0. After we have taken the action, the environment will return the next state and reward. We accumulate the total reward until the terminal state. So we run the model, and this is the result. So you can see that we actually max out the total steps of 200 allowed for this gym, since the taxi did not reach to the terminal state, and our reward is minus 200. So to do the SARSA reinforcement learning, we will first define an action policy function. So this action policy function will follow and implement the epsilon greedy algorithm. Next, we will do the SARSA reinforcement learning. We choose a gamma of 0.9, epsilon of 0.1, and 50,000 episodes of training. Prior to each training, in the loop here, we will first pick an action using the epsilon greedy algorithm. You can refer to my previous video on the explanation of epsilon greedy algorithm. We apply the action to the environment, and the environment will feedback the next state and the reward. Given the next state, we can pick the next action based on the current Q value using the greedy algorithm. Next, we will update the Q table using the Bellman equation. But instead of choosing the maximum Q value or the optimum policy for all possible action as in Q-learning, SARSA only updates the Q table based on 4 values: the current state, the current action, the next state, and the next action. Next, we will update the current state with the next state and the current action with the next action. So this is the result that after we ran the 50,000 episodes, we print out the Q tables. We got an array of numbers. Some are positive and some are negative. Let's run the model again with the trained Q table. Similar to the Q learning, we observe a huge performance improvement after the reinforcement learning. We reached the terminal state only in 14 or 13 steps, and we got a reward of 8. And this performance is just slightly worse than the previous Q learning. This concludes the video on Q learning. The code for the video can be downloaded below. We welcome your comments below.